Hey guys, in this video we're going to be talking about finding limits with some trig examples. So our first one is the limit as x approaches pi over 2 of 3 sine x. The first thing you want to notice is that x is approaching pi over 2, not 0, so we couldn't use one of our special limits if we needed to. Our first step when we're solving limits is to always see if we can just plug in the value that x is approaching for x. So if we were to do this, we would have 3 sine of pi over 2. And this is where our unit circle comes in handy. So you'll want to have this memorized still from trig. So we'll just sketch out a little one with just the information we need. So if we're looking at pi over 2, it's going to be up here, and our coordinates there are 0, 1. So remember that our cosine x would be the 0 and our sine x would be the 1. So in this case, we would have 3 times sine of pi over 2 would be 1. So our final answer is 3. Let's do another one. This one is a little bit trickier. So if we were to plug in 0 for x, we would end up with a 0 in the denominator, which is not allowed. So we need to figure out another way. So notice that in this case, x is approaching 0, so we might be able to use one of our special limits for trig. In this case, we're working with tangent right now, so there's no special limit that uses tangent, but they do have some that use sine and cosine, and we can rewrite tangent as sine and cosine. So remember that tangent x is equal to sine x over cosine x. So that's one of my biggest tips when working with tangent is to rewrite it in terms of sine and cosine. So in this case, we have tangent squared x. So we're going to have to use sine squared and cosine squared. So let's start by rewriting our limit as x approaches 0. In this case, we have sine squared of x over cosine squared of x, all over 2x. This is getting a little bit crowded, so let's go ahead and rewrite it by splitting these fractions. So we'll separate them. The limit as x approaches 0, and we'll write our sine squared over cosine squared, and then we'll write our 2x off to the side as 1 over 2x. So we have sine squared of x, or cosine squared of x, and then we have our 1 over 2x. So we're getting pretty close. Now we're working in terms of sine and cosine, but we need just one of those, not sine squared or cosine squared. So what I see here is that we have sine squared x here, and we have an x in the denominator over here. So if we can get it in terms of just one sine x and then move the x over, we can use our sine special limit. So let's go ahead and separate sine squared x over cosine squared x. So we'll have the limit as x approaches 0 over cosine x, and then that'll be multiplied by another sine x over cosine x. And then finally, we'll have our 1 over 2x. So now we have the components for our sine special limit. And if you need a reminder on that, you can watch the video on special limits. So we have a sine x numerator, and we have an x in the denominator. And since this is all multiplication, we can rearrange the order without changing the value of the problem. So we can rewrite this as the limit as x approaches 0, and we'll have our sine x over x, and then we'll write everything that's left over. So we'll have a cosine x left over in the denominator, have a sine x over cosine x, and then we'll just have a 1 over 2. Now, remember we can take the limit of each of these individually and then multiply them together. And our big problem was taking the limit when we replace 0 for x, we'd have that 0 in the denominator. But now that we have it in our format for our special limit, we know that the limit as x approaches 0 of sine x over x is always equal to 1. So that takes care of our problem with having the 0 in the denominator. And then we can go ahead and substitute 0 for x in the rest of these. So we'll have 1 of cosine 0 times sine of 0 over cosine of 0 times 1/2. Again, let's go ahead and draw ourselves a little unit circle. And remember that at 0, our coordinates would be 1, 0. So our cosine of 0 would be 1. Our sine of 0 would be 0. And we'd have another 1 for cosine of 0. And then we'd have 1/2. Since we have a 0 here, 0 over 1 is just 0, and when we multiply everything together, our final answer would just be 0. Last one, we have the limit as x approaches pi over 2 of 2 cosine x over cotangent x. So pause the video, take a moment, and try to figure it out on your own. Go ahead and do it together. So if we were to plug in pi over 2 for x, remember our unit circle, pi over 2 would be 0, 1. And remember that cotangent of x is equal to the opposite of tangent, right? So it would be cosine on the numerator and sine on the denominator. So if we were to plug in pi over 2 for cotangent x, then we would end up with a 0 in cosine x. So that would put a 0 in our denominator for our limit. That we can't have. So we have to figure out another way to solve this. Again, like my suggestion with tangent, I would suggest getting this into terms of sine and cosine in order to work with that. This time, though, we will not be able to use a special limit because we're approaching pi over 2 instead of 0. Let's still try to get this in terms of cosine and sine. So we'll rewrite cotangent as cosine over sine. First thing I'm going to do, though, is to rewrite this because it's going to get a little messy with compound fractions. So let's go ahead and rewrite this fraction as just being divided. So we'll have 2 cosine x divided by cotangent x. Now let's rewrite cotangent as cosine over sine. So we'll have the limit as x approaches pi over 2, 2 cosine x divided by cosine x over sine x. Now what can we do? Well, if we're dividing by cosine of x over sine of x, that's the same as multiplying by sine x over cosine of x. And if we do that, then we'll be able to cancel out the cosine factors. So let's rewrite this as the limit as x approaches pi over 2 of 2 cosine x times sine x over cosine x. Now, a cosine here and a cosine in the denominator, so we can cancel out those factors. This is perfect because if we were to try to just plug in pi over 2 again, we would still have that 0 in the denominator, so we needed to get rid of that cosine. Now we can write it as the limit as x approaches pi over 2, and all we're left with is 2 sine x. Now we can go ahead and plug in pi over 2 for x. So we'll have 2 sine of pi over 2. Remember, sine of pi over 2 is just equal to 1. So we would have 2 times 1, and our final answer would just be 2. Thank you for watching. I hope this helps.